Okay, so now let's do all the steps, but let's automate it using something called a make file, like one single configuration file that has all the commands. It will execute all of them in one go, right? So you don't have to type every single command out every single time to compile. Yeah, so I've actually deleted all the .o files and the app executable, so we can do it again. And I've added back the lib_impl file, impl.cpp file, so we can compile the library as well. So let me open up Makefile and show you what it looks like. So this is just a variable, cxx equals g++. It means that it's just setting the variable to g++. And cxx flags is also a variable, and it's just setting some flags. Here, something important to note is that I'm setting the C++ standard to 20. So you can specify which standard C++ to use. Right, so this step is where the linking happens. Like if you remember, we linked two files together and we made the executable. So that's basically what we're doing here. So app is called a target, like everything before a colon you see here, it's called a target. Like remember this word, target. In fact, I'm gonna write it down because it's really useful, in CMake terminology as well. We're going to get to it later, right? So we have the app target, which depends on app.o and lib.o. And well, they're not built yet. So what it's going to do is it's going to go ahead and build those first, right? So what does app.o need? It depends on app.cpp and lib.h. So we have app.cpp and lib.h. The command it's going to execute to build those is specified right here. This is just going to expand to G++, and it's going to add the flags here and compile, -c, compile, app.cpp, and the output is app.o, right? Similarly, the lib.o target also produces the output. The output file is lib.o, right? So after it builds this, it builds the final target by executing this command, which is like the linking command, and the output is app, right? So that's basically it. Like you have written the same exact thing in one file, and that's a config file. Right, so let's execute this. So the way you do it is with something called make. Make is a command line tool that you use to execute like make files. And I'm just gonna hit enter and look at what it did. Like it expanded the commands, it's G++, it's making app.o, and then it's making lib.o, and then finally it makes the executable. Like, so if I run the executable now, it's gonna print the same exact thing. And yeah, so this is how you can automate things in Linux. There is an equivalent thing that you can do in Windows as well, but normally people who develop in Windows, they use VS Code, Visual Studio. They can also use VS Code, but Visual Studio is really popular, and it has its own like similar thing where you can like specify some configs and it will compile the code for you. Let's jump into CMake now. Finally, we're getting into CMake. Now, CMake is something called a meta build system, meaning that it's not exactly a build system, but it's a configurator program. It will generate the config, or it will generate the build system based on the config you specify. In the CMake world, the file called CMakeLists.txt, a text file, is the format, the config file format. And everything you specify here, CMake will read it, and it will generate a build system for the intended platform, like I told you about. So Windows, or maybe like Linux. Here, it will generate like make files. In Windows, it will, I don't know, I exactly don't know. Maybe it's like Visual Studio files, or I don't know, some format which you can use to run and build your program. In Mac, there's similarly another platform. And CMake can also be used to generate the build system for like embedded devices maybe, and like devices with restricted processing power, because we're dealing with C++. So like maybe embedded devices. So it's used everywhere, and that's why CMake is really, really popular. All right, so let's go ahead and write the same exact thing with CMake instead, and generate a build system for Linux, and let's see how it looks like, right? After doing this example with CMake, we're going to jump into the Game Engine project and see how how CMake works in detail, and we can jump into writing a good project structure for a professional Game Engine project, right? So let's go back to the folder, and so what I've done is I've deleted all the .o files and the executable, and we're back to this now. Right now we don't need the make file because CMake is going to generate one for us, but I'm just going to keep it just in case, like we can use it as a reference later, probably. And right, so let's write some CMake, right? So like I told you, the config file in the CMake world, it's called CMakeLists.txt, list.txt, right? I'm going to open this, and actually I'm going to go to the CMake website now, cmake.org, and click on the Getting Started section, and I want to click on the CMake tutorial, and let's go to getting started, right? Okay, so let's scroll down, and I'm gonna copy these lines, and I'm gonna paste it. So this is how you start with the project. These two are pretty much crucial, and all you're doing is mentioning the CMake minimum required version. Now, ideally, you would want to do the CMake version that you have. I'm gonna see my version. So it's like 3.28. I'm just gonna keep it as 3.23, and I'm gonna name it differently. Like I'm gonna make it like my game project, my game engine, right? Yeah. So there's also another thing you can do. You can put in the version. You will see how it's very useful when we're gonna do the game engine project next. So let me quickly finish this example. Now, what I want to do is like, remember I told you about targets. Like I'm gonna go back to the website and show you something that is very cool, very crucial. I think it's right here somewhere. Target, yeah. So in CMake lingo, a target is a name the developer gives to the collection of properties, right? A target can be an artifact kind. Like in our case, a target is a library. It can be an executable. It can also be a header collection, which means that you can specify some of the headers, and you can like bundle them together and name it a target. And you can use that target while installing, or you can use it to link with other targets, and like there's many things you can do just by grouping some properties together and naming it a target, like naming it a target. Let me demonstrate. So right now I'm going to add a library with a target name. I want to give the target a name, and I'm going to give it like the name lib. I'm going to do the same thing like I did in the previous example with Makefile, and I'm going to add this library, and I'm going to, like, by default the library is going to be static. Remember I told you like a bunch of .o files can be bundled together, and it can make like a .a static library. So that's what we can do here. Like we can specify either it can be either a static library, or it can also be something called an object library. Again, we're going to get into it when I'm going to do the actual game engine project in a moment, but we can do it like this as well. I'm just going to keep it static for now. And we also need to add an executable. I'm going to add the executable, and I'm going to name the target app, right? I'm going to name the target app, right? So the next thing we're going to do is target sources, right? And we can give this target some sources, like what the source files are for the lib target. I'm going to use the keyword public. So I'm going to specify that, oh, hey, so this everything that I'm going to specify here, all the sources that I'm going to specify here, they're all public to this library, which means like other targets, like let's say some other target like app, when it's linking to this library, it can access these, like it can see all of these as well. Whereas if I name it like private, it cannot, like the app, once the app is linked to the library, it cannot see all the files that I mentioned here, right? We're going to talk about that in much more detail when we do the game engine project again. But yeah, just giving you a basic overview. And lib private, and I'm going to do lib implementation impo.cpp, because the reason I'm doing it private is because it's a CPP file. The implementation, like this file will never be used by app or any other target that links to the lib library. So there's no reason why this should be public, right? All right, so, but we want to provide the lib.h source as a public source, right? So let's do that, lib public and lib.h, but you don't do it straight away like this. I'm gonna group it and make it into another target. Like I'm gonna demonstrate in a bit. So I'm gonna say public file set. So a file set is something like a collection of files, and I can name it like headers. This is the name of the file set. Well, I can actually call it my headers as well. My headers. You can name it whatever you want, but the convention is calling it capital headers. I don't know like why sometimes like they decide to do things in capital letters and sometimes in small letters. I don't know, but I think what you can do is like you can just like make headers here, and you can also like specify the type as headers, right? Type headers. If you want to name it the same thing, you can just omit this type altogether, right? And yeah, so that's why it's headers. I know it's confusing. We're going to get to it later. File set headers, and the headers are, well, I'm going to have to specify that it's a file, right? Like files, lib.h. Again, by the way, I'm not doing this from memory. I've done this many times, so I know this. But normally how I would do is like if I don't know how to use this, I'm just going to go to the CMake documentation, and I'm going to go to like documentation, and we're going to go to the reference documentation, and like CMake, because it's a CMake command, I'm going to go here. I'm going to search for target underscore sources is what we're looking for, right? I'm going to open the target source, and then I'm going to read this, right? So yeah, I normally read the whole thing because it gives you like a much better understanding about what's going on, and it's really good. The documentation I highly recommend. Just like follow the official document. You don't even need to like search on Stack Overflow or anything like that. So target sources, so it says you specify the name of the target and the scope, which means the public private keywords, and the file set. Like I told you, you can specify a file set, and you can like name the target, like the set, and you specify the type, and then you add like some base directories. I'm going to show you this later, but we're not going to touch this now. But except now we're just specifying all the files required, and then giving all the files here, right? So that's what we're doing. That's usually how I do. Yeah, I'm just going to leave it right here. So now we've specified all the sources that the lib needs, and we're done with the lib. Now let's do the same thing for add executable as well. The sources for this one, this target app, is there anything public? No, we don't need anything public. So it's, but there is one private source that we have to mention, which is like the app.cpp. Because it's an executable, it's just gonna like give us the final file that we can use to run, right? So I believe that's it. That's all you need, right? Oh, we forgot one crucial thing, which is like, okay, we've done this, but we forgot to link it. So what we're gonna do is target link libraries, and we're gonna link app to lib, but we're gonna make it private, right? Private. Again, you can just like go to the documentation and see the exact signature of all the of this command. So anyway, I'm linking the lib target as a private library because the app is the final executable, and the app is not going to be linked to any other target in the future. So yeah, so we've done this, and let's go back here, and okay, so I'm going to show you the commands, all the commands available. I'm going to go here, I'm going to click this and the command line tools. So yeah, so what we want to do is we want to generate a build system, right? So that's what it says here, generate a project build system, right? So because I'm using Linux, like currently my operating system is Linux, it automatically detects that and it produces some make files. But you can also specify what build system to use. You can just like go through this and you can see how to do that. But right now I'm just gonna like use this. And so like it says CMake options and -b and a path to build, and -s a path to source. So that's what we're gonna do. So we're gonna say CMake -b build. Actually, I'm not gonna build it like in this folder, because it's too much. I'm gonna make, normally the convention is to make a build folder like this and put all the build stuff in that folder, because as you'll see in a bit, it will generate a whole bunch of files that's like it's just ugly. Like if you put everything here, it's not nice to look at, right? So I'm gonna say build folder is the path for the build folder is gonna be build, and the source is the current folder that I'm at. Okay, so I'm gonna do this, and it says build files have been written to this, right? So I'm gonna go back to here, and if you look at this, it has a bunch of CMake files, like all of the CMake related stuff, and there is also a make file, right? So if you look at the make file here that it generated for us, you can see that it has similar things that we did in our make file previously. It's making a target to build an object file, and it's pre-processing it, it's generating an assembly file, and it's doing all of these steps. But there's clearly some extra stuff that's going on here, right? So let me first talk about something that's very trivial. So remember what I told you earlier, that CMake is called a meta build system, or it's also called a configurator program. Now, what it did is that it configured a build system for us by reading the CMakeLists.txt file, okay, or also called a CML file. From now on, I'll just call it CML file because it's easier to say. But yeah, it went through all the config that we wrote in the CML file, and it generates a build system for us. And in our case, it generated a build system for Linux, right? Because our operating system is Linux, or my operating system is Linux, and it generated make files. So what it did is it went through a few stages, just like how I told you that C++ compilation process goes through a certain number of steps, like preprocessing and then assembly and then compilation or whatever. Similarly, CMake also has some steps involved. The first stage is configuration stage, and the second stage is generation stage. And the next stage is technically build stage, and then finally the install stage. I feel like lots of tutorials online about CMake, they don't really talk about the install stage at all. I don't understand why though, like because install stage is the end result, and that's the whole point of using CMake in the first place, right? You want your applications to install. You want your users to be able to install their applications in their clients' machines. So yeah, I don't know why lots of CMake tutorials just straight up skip the install stage. Anyway, so these two are technically outside CMake's domain, but we can still use CMake to like do these things for us. And in fact, it's recommended. So we're going to talk about this, don't worry. So what we just did is we just went through configuration stage and generation stage, right? In the configuration stage, it just goes through the commands line by line and sees like all the like it checks for variables, like expands all the variables wherever they're used, and it's like it goes through the commands like, hey, if we say add underscore library, and it thinks that, oh, okay, this person wants to make a library, and then if we say like add executable, and then it thinks that this guy wants to make an executable, and then when we say target link libraries, it's gonna it's gonna read all those commands, and it's gonna understand like what we're trying to do, right? So after that, it moves on to the generation stage, where the actual generation of the build system happens. Like it generates all the files that are specific to the platform, like Linux. Well, in this stage, you can also tell CMake to generate it for another platform, just like I told you. It can generate it for Windows or Linux or any embedded devices. Yeah, so what we did is we went through these two stages, and the result of that is this whole thing. So that's why it has like, in the make file, if you take a look at it, it has so many other things, and we have not built it yet. It just configured and generated all the build system for us. So now what we can do is we can actually build the project. So I'm going to cd into build, and I'm going to use make again. Well, normally how I do it, and the recommended way of doing it, is like use the CMake command line tool instead of make, because make is very specific to Linux. But now I'm just gonna, to demonstrate that it's very similar, I'm just gonna use make as well again, and I'm gonna hit enter. So if you take a look at it, what it did is it built the target app, it built the target lib, it built a static library called liblib.a. Why liblib.a is because like I named my target lib, and in Linux what happens is like the convention is to prepend the word lib before the target's name, before the library's name. So that's why CMake knows what the conventions are, and it tries to make it as close to the conventions as possible. So that's why we have liblib.a instead of lib.a. And if you remember, what is .a? .a is a static library, and let me show you here. Let me write it down, because we're going to be dealing with this a lot. So the libraries in Linux are like .a is a static library, and in Windows it's .lib, I believe. And similarly, we have .so, which is a dynamic library, which means you can link to it at runtime. I'm going to talk about it later. Or it can also be called a shared library, and I think in Windows it's called DLL, right? So it's the same thing. I don't know about Mac. I don't use Apple devices a lot, so I'm using an iPad now, but I don't really use Apple for like as a computer. So anyway, it did all the things for us, and it made an app, and it made liblib.a. So if I actually run app, it should print the same thing that we got last time. Yeah, and it did. So that's it. So I'm actually gonna delete these, and I'm gonna do it again with CMake this time, CMake build, and I'm gonna specify this, enter, and it did the same thing again, right? It did app, and it did liblib.a. So the recommended way of doing it is using CMake, but just to demonstrate, I used make. Right, so so I want to show you the libraries that are installed in my computer, just to show you that every time you install a software or an application, all it does is it copies the static libraries into your system folders, which you can find if you go to cd slash USR, which means the user, and enter. And if I list, so there's a bunch of folders here, right? Like bin, games, include, lib, and you see there's like lib folders here. They're all folders that contain libraries. Like, let me demonstrate. Like if I go to lib, okay, I'm gonna clear this and I'm gonna list this, right? So they're all folders. Again, there's many applications, there's many folders. But if you take a look at the files, actually I'm gonna use the other ls command instead. So if you take a look at this, .so, remember I told you that .so is a dynamic library, right? So that's what we see here. We see .so files, right? And I bet there's also some .a files. I'm gonna do a quick find in this folder all the letters, all the things that start with .a, right? And take a look at that. There's many static libraries here, right? In Python has some libraries, and like, I think this is the GNU compiler, C++ compiler, Windows compiler. And yeah, so there's PyMath, you know, NumPy has like installed a, it installed a static library, right? Similarly, there are some here as well, like in these folders as well, right? So yeah, so all you're doing is installing your binaries, or sorry, your static libraries. And you can also take a look at what binaries contain, right? If I do ls, and you'll see that all of these are like there's some folders as well, but they're all apps. Like if you do it in Windows, the analogous thing of opening the system files in Windows is if you open program files or program files 32-bit or something, like you find folders like bin, and inside the bin I think you'll find .exe files as well, some executables. So they're all executables, right? So now I want to show you something really cool, which is we went through the build step now. Now let's do the install. Okay, we never mentioned install until now, but that is the end result that we're looking for. Okay, now let's proceed and install. I want to install targets. I want to install lib, and I want to install app. Well, I don't want to install app just yet. I'm just gonna comment this. And I want to install some file sets. I want to install my file set called headers. This is the name of the file set. You can provide a file set, and you can name all the files here. And like maybe there's another library called lib2.h, and similarly there's a lib3.h. There can be like many libraries, that many header files that you can group into one file set and call it headers. And you can install them here, right? You can use the file set to install. And I'm gonna close this, and that's it. Well, all it's doing is installing this. Well, this is a very crude way of doing. I'm gonna like clean it up in just a bit, but just to show you what install does, I'm gonna go back and say CMake install. Well, I'm gonna create a folder called install, just like how I did with build. I want all the install stuff to be here, and I'm gonna say install the binaries that are in the build folder to a folder called. Okay, I'm writing the word prefix because I've used it many times, like I told you before. But if I don't know that, what I would do is that I would go to the documentation, reference documentation, and I would look at the command line tools, because this is the command line tool, and I'm going to click at CMake, and we did the project, and we built the project, and we want to look at this one, install a project, and CMake directory and options, and in the options we can specify a prefix. A prefix is an alternative installation prefix, temporarily replacing the value of CMake install prefix. So if I didn't provide this prefix, what it would do, it would install all the it would install all my binaries and libraries into like the actual like into my system folders, which is the user or user/local. But I don't want to do that. I want to do it in a separate folder right here, and which I just created, called install. I'm going to do this, and look at what it did. It said installing the library called lib.a and lib.h. And if we take a look at the folder, look at what it did. It's created an include folder, and it created a lib folder. But nowhere here we specified the folder include or lib. It did it by default because it knows that we're dealing with Linux, and it knows the conventions for Linux, and that's also why it prepended the word lib. Because if you take a look at the folders that I told you about, like cd and cd into lib, and if you take a look at the folders, so lots of the files are like prepended with lib, the word lib, right? And I'm just going to quickly find again, find .a files. And if you take a look at them, they're all prepended with the word lib. See, like libsocket, libglu, libc, libxi, whatever, right? So it knows. It also knows the conventional names for the folders, like specific to platforms. Like if you take a look here, there's include, there's lib, and yeah. So if I go to include folder, and if I list, look at what it contains. I'm going to do ls. Look at what it has. It has all the header files, right? So technically, all of these files, all of these header files, you can use to, like, you can make another application and you can use these header files and the corresponding binaries, maybe in bin folder, or maybe the corresponding libraries are in lib folders. And you can use all of these and link against the libraries, and you can use it in your own thing, right? So for example, stdio, io.h, when you say include stdio.h, it comes from here, right? Like the compiler knows that these are the default folders for Linux, and it's going to find them here, right? And that's why it created a folder called include, and it put the include, the header files in the include folder, and it put the libraries inside the lib folder. Now, if I had done this without the prefix, it would go ahead and install it in my system files. Let me do that. Permission denied, because it's trying to install it in my system folders. So I'm going to do sudo now, sudo CMake install all the files from build into, into my system folders, and I'm going to hit enter. Yeah, it did. It installed into user, local, lib, and user local include, right? So now any app that's anywhere in my computer, it can access these two files, lib.h and liblib.a, which means this is the binary and this is the header file. So our library is kind of accessible to every single application in our computer, right? So so yeah, that's what it did. I'm gonna delete, well, if you want proof that it actually did it, I'm gonna go to my local, and I'm gonna ls, and I'm gonna ls lib, and yeah, would you take a look at that? It has liblib.a, it also has libvulcan.so. So yeah, it installed my library, and I'm gonna ls include as well to see if my, yeah, so there's only one header. But yeah, this is how it works, this is how it installs. I'm gonna delete that from my system folders later, but now let me delete all of these again. So the reason I showed you this in a crude way is to show you how simple it is to use CMake to build and install. So all we did is we specified the project information here, and we said, hey, we want to add a library, and we're going to get to all these commands in detail. So I'm going to slowly convert this whole project progressively into an actual game engine project, which is kind of more professional. And by the end of this video, you will have a full project which you can download through GitHub. I'll probably upload it to my GitHub, and you can download it and you can use it as a base to kickstart your own game engine project, right? So yeah, so right now it's just a very simple library. And if you notice, I haven't installed the app, like the actual executable, app executable. I only installed the library, and I only installed the headers, the public headers. In our case, there's only one header. Right, so let's install app as well, right? So why not? I'm going to clear this. I'm going to say I'm going to generate the build system again. CMake generate build system. The source is the current folder, and the build system should go into build folder. And now it did. Now I'm going to have to do build and build everything that's in the build folder into the same folder, and it built the target lib, and it built the target app as well, right? So in the build step, we're not specifying anything about installation. All the installation information we're only specifying in this one line, right? So I mean, we're defining all the targets beforehand, and then we're specifying those targets in the install command. So in this install step, build, install everything from the build. Basically, it just copies all the binaries and it copies into the install folder. So I don't want to install the app in my system folders again. So I'm going to put a prefix now. I'm going to say install everything in the install. And now it installed application as well. Now, if you look at it, it installed in the bin folder, right? So it knows like the Linux conventions, and it just automatically installed in bin folder, right? So yeah, so leave it to CMake. Like all this stuff, I see people like manually specifying all the directories, like target include directories, and all these crazy stuff. You don't need to do that. In Modern CMake, you can just use this one command. Like you can use targets, and you can use the commands that are specific to targets, like target sources, like the one that we're doing right here, target sources, and you can specify all the information about target. Remember, a target is just a collection of properties. So in this case, I'm saying lib is a target. So in this case, a library. I'm just saying that this lib library, everything that's related to lib, I'm just calling it one target, and I'm specifying the sources for this target here, like header files and the implementation files. And I'm also specifying the scope, like is it private, is it public, all of that in the target sources. And then I'm saying add executable, and this is also a target. App is an executable target, and I'm giving the target sources again, and I'm just adding the implementation file for app as well, and then I'm linking the target. So that's it. Like if you use CMake, you should heavily rely on the target system rather than manually adding everything by yourself, because if you do that, you're going to make your life much harder. So that's what I wanted to show here in this very simple example.